Hi, my name is Max Morin, Managing Director of Kinnem Robotics. Scissor lift tables are hoisting devices used in many industries, being the automotive industry one of them. If well designed, these devices can lift safely very heavy loads in a short period of time. In this video we are going to show how to obtain the technical data for the selection of a suitable geared motor. Design constraints. Payload 3 tons. Lifting height 1 meter. Lifting pause and lowering times, 6:1 and 6 seconds. Criteria. Electric motor speed, 3000 RPM. Load and gears efficiency, 90 and 95%. Thermal considerations, not considered. Motion type, sinusoidal, variable speed drive control. The simulation is performed in our software. The output shaft angle, angular speed and acceleration, power, overhung force and torque data is obtained for the whole movement cycle and processed in our calculation spreadsheet. Here, the load and gearbox efficiency are included in the new calculations. Also, the gearbox ratio is calculated considering a 2-poles electric motor. Now, we have specific related data for the gearbox and electric motor selection. In relation to the gearbox, we can see the most important graphs, as well as numerical information on the data table. As expected, for this application, we can see high output torque requirements when the table is in a low position. The same happens for the maximum overhung values. Similarly, we can see important graphs and numerical data for the electric motor selection. On the first graph, the maximum torque on speed range, we can see the high demand of torque for the application at no speed. However, on the output torque versus time graph, we can see that this high torque demand decreases very quick. Nevertheless, the selected motor has to be able to supply this static torque demand, otherwise, it won't be able to lift the load. The best motor selection for this application is a servo motor. Servo motors can deliver and maintain high torque at 0 speed. This is called static torque. A good variable speed drive and servo motor selection can allow a servo motor overload for some seconds. Let's suppose that we can allow an overload for a short time, let's say, 1 second. The nominal static torque required will be equal or higher than 100 newtons. With this information we can draw the torque versus speed curve of the application. Please remember that thermal considerations are not included in this calculation. The geared motor manufacturer is responsible of this task. Calculation conclusion. Gearbox type, high efficiency. KR or F. Output torque, bigger or equal to 12 kN-meters. Output speed, bigger or equal to 31.1 RPM. Overhung load, bigger than 27 kN. Ratio, lower or equal to 96.4. Motor type, servo. Output torque, bigger or equal to 100 Nm, static. Output speed, equal to 3000 RPM, 2-poles motor. We hope you liked this video. Should you have Mechatronics project planning requirements, do not hesitate in contacting us. Please subscribe and follow us for more interesting mechatronics, robotics, and control systems video content. Thank you.